Welcome, dear students. In this video, I'm going to discuss with you the time value of money, which is a very important chapter of uh, financial management for BCom course, right? So what is this time value of money? We are going to discuss and how it is ascertained. The value of money, today's money is much more than tomorrow's money. So how it is all and how we are going to calculate the time value, future value as well as present value. So in this video, I'm going to discuss how future value is ascertained when a compounding rate of interest is there and when simple rate of interest is there, right? So let's move on to the meaning of time value of money. So the value of money received today is different from the value of money received after some time in future. The concept of time value is that the value of money received today is more than the value of the same amount received after a certain period of time. In simple terms, money received in the future is not as valuable as money received today. So the diagram explains, the chart explains over here, the time value of money. See, look at this. The value is O, Y axis shows you the value and O X axis shows you the period of time. So here, the today dollar is $10,000. The value of $10,000 is here today, and it goes on declining, it goes on declining. After 5 years, the value of $10,000 is less. Value proportion is less over here. And the same case, if you look at the 10th year, the value is too less. So same amount after so many number of years, it loses its value as and when the days pass on, right? So that's why we, how do we calculate? There are techniques of time value of money, no? So there are mainly two techniques. One is compounding technique, that is also called as future value technique, and another one is discounting technique, which is also called as present value technique. So let us discuss one after one. In this video, I'm focusing more on compounding technique, that is ascertaining future value. So using simple interest as well as compounding interest. So let's come to the compounding technique or future value technique. The time preference of money encourages a person to receive the money at present instead of waiting for the future, right? But he may like to wait if he is duly compensated for the waiting time by way of ensuring more money in future. For example, a person being offered rupees 1,000 today may wait for a year if he is ensured of rupees 1,100 at the end of 1 year. Taking his time preference for money is 10% per annum. It means if we offer you, if you give an option to you that rupees 1,000, I'm offering you the same rupees 1,000 if I pay you after 1 year, which one do you accept? The first one, that is today receiving rupees 1,000 so that you can invest elsewhere and earn more money. This is what time value factor. If I offer you that I'm not paying you after 1 year the same amount, 1,000, but I'm adding something more. It is 10% of that. You are going to get more. That's 1,100 rupees after 1 year. Then you may say that, okay, no probes, I will receive it in the next year. This is what the crux of this. Okay. So compound interest. What is compound interest? If interest for one period is added to the principal to get the principal for the next period, it is called compounded interest. What is this? If interest for one period is added to the principal amount, it means principal plus interest, and next year it will be principal added interest will become the principal amount. Say for example, what is compounded interest, So here, let me tell you, if 1,000 rupees you are investing at a 10% rate of interest, the 10% will be rupees 100 and 1,100 will be your total sum. Future value is 1,100 for the first year. After completing first year, you are getting 1,100. If you deposit the same, annual compounding will be there. That's why it is 1,100 will be the principal on this 10%, that is 110 rupees will be your interest. So 1,200 10. Right? So this is what the interest part is added to the principal, then it becomes, the principal amount becomes 1100. This is what is compound interest or a compounded interest is. Next year, the compounded interest, no problem, no confusion here. It is 10% only, but not 10% on rupees 1000, but 10% on rupees 1100. So that's why the interest part is 110 rupees. Okay. So this is what, is called as compound interest. Let's move on to the next part, that is compounding technique or a future value technique, how it is ascertained and what are the classifications made over here. Compounding technique or a future value technique may be classified as follows. One is called as future value of a single flow. Single flow is one-time investment, one-time investment for number of years. So that is what we call it as lump sum investment. So single flow it is called as. Second one is future value of multiple flows. That is 1 year, some amount you invest, next time again different figure you are going to invest, right? This year I have invested 1 lakh, next year 1,50,000, next year 2 lakh, likewise different amount is going to be invested. This is called as multiple flows, right? So the investment made in this is different every time. But third one is future value of an annuity. Annuity is a series of amounts. Series of amounts are same for all the years. If I go on investing every year 1 lakh, every year the same amount I'm going to invest, that is known as annuity. Okay. So let us learn how do we calculate if a single flow is there, lump sum amount is there, right? So what is that future value? Lump sum amount, single flow amount calculated, how it is calculated, how do we ascertain the future value of a single flow, right? The future value of a lump sum can be calculated by using the following formula, that is future value is equal to P multiplied by 1 plus I raised to n. This is what the formula. It can also be written in this way, right? So future value is equal to present value multiplied by 1 plus r raised to n. So we can make use of these notations or else the first one also. Both are one and the same. So where FV is equal to future value, P means principal amount, I is for rate of interest per unit, that is R divided by 100. How do we get the per unit? It is calculated as R divided by 100. If it is a 10%, 10 divided by 100. What do we get here is 0.1. So if it is 5%, 5 divided by 100, the amount we get, the rate we get is 0.05. Likewise, we need to calculate it per unit. Then number of years, n is meant for number of years. It is raised to n is there now. So that is number of years. So same formula here also, notations are different. FV, future value, is equal to present value multiplied by 1 plus r raised to n. Okay. So the same second formula is presented here. The formula for future value is FV is equal to PV multiplied by 1 plus r raised to n. So what is this FV is? FV is meant for future value. PV is nothing but present value, and 1 plus r. So this r is represented in different ways, One is rate of interest, you can call it as rate of return, right? Or discount rate or interest rate, or growth per period. It can also be called as growth per period, right? So by using this formula, we can calculate future value of a single flow, right? So here there are two concepts, one is simple interest, one more is called as compound interest. If simple interest is there, little bit of change will be there in the formula. And if compound interest is there, just now whatever you have seen, that will be shown. In the first box, it is future value when simple interest is applicable. What is the formula here? You can, see here is equal to present value multiplied by 1 plus I multiplied by n, right? So it is written in sub bracket, this is sub bracket. I is rate of interest is multiplied with the number of years. then complete the bracket. It means here this formula is little bit different as compared to the future value when compound interest is made. Okay, so what is this? PV multiplied by 1 plus I raised to n. So whole raised to n is there. It is 1 plus I raised to n is there. Whereas here it is not 1 plus I raised to n, but 1 plus bracket into bracket I multiplied by n, complete the bracket, then the whole bracket completes, right? So how it is calculated with an example, we will get to know what is the difference if we ascertain the future value using simple interest, taking simple interest and using compound interest. So what is that difference we are going to see here in this problem? Okay, now problem is the simple problem. First one, future value of rupees 8,000 for, find out, we need to calculate future value of rupees 8,000 for 4 years at 12% simple interest per annum, and also future value at compounded interest. Okay, so same amount, same number of years, same rate of interest, but in first case it is a simple interest, in the second case it is a compounded interest. So let's move on to the solution. Future value, simple interest is there. So write the formula here. PV multiplied by 1 plus I multiplied by n, complete the bracket, and the whole bracket also completes, right? So here 8,000 is a PV, that is present value. The amount which is going to be invested is rupees 8,000, and 1 plus I multiplied by n is there. So how this is all is done is 1 plus I. What is the I here? 0.12. Okay, and multiplied by how many years? 4 years. This is what we do the multiplication first. Completely we'll have to multiply these two. That is 0.12 multiplied by 4 years. So when we multiply this, we will get the answer as 0.48, and 1 is added to this. 1 plus 0.48. This becomes 1.48. That is what we have arrived here. Okay, so that is 8,000 multiplied by 1.48. We get the answer as rupees 11,840. If you invest 8,000 rupees for 4 years at the rate of 12% interest, simple interest, then the amount, the sum, the future value will be 11,840. 8,000 is increased to 11,840 after 4 years at the rate of 12% simple interest. Okay, coming to the future value using compounded interest. So here compounded interest formula is little bit changed. That is PV multiplied by 1 plus I raised to n. So this is what we know is 1 plus I raised to n. What is the I? Here 0.12 raised to n. N is 4 years. It means 4 times we are multiplying this. 1.12 into 1.12 into 1.12 into 1.12. So if you multiply it with 4 times, then we derive one factor that is called as compound value factor. That is we are getting here. Then that compound value factor is multiplied to 8,000. Then we derive 12,588. So this 12,588 is for compound interest, whereas 11,840 is for simple interest. The difference between these two, that is the difference between the simple interest and the compound interest, is rupees 748 more as compared to the simple interest. If simple interest is there, looking to these numbers, in the problem, 8,000 rupees, same amount, 4 years, here also 4, there also 4, 12% rate of interest is there. Here in the simple interest also 12%, in the compounded interest also 12%. But the difference, look at this. How much more are you going to get after the end of 4th year if compound interest is there? That is 748 rupees more, because every year the interest part is added to the principal amount. Then on that, the rate of interest starts, right? So it earns on that which includes principal plus interest. On that, interest is calculated for the next period. Okay, so this is what is the importance of compound interest. So always we prefer to invest our money for the compounded interest, not for the simple interest. Okay, let's move on to the next problem here. This is purely compounding annually. Compounded interest only we are calculating, but annually compounding, the same thing, whatever we have done in the last problem, the same thing is there. And there is a scope also that quarterly compounding, semi-annually compounding, annually compounding, monthly compounding, all these options are there. Usually bankers quarterly compound the interest. They add for every 3 months what is the interest that is calculated, that is added to the principal amount, and next from third month onward, after third month onwards, the principal plus 3 months interest, whatever the amount we get on that, interest is charged or interest is calculated. Okay, so every 3 months they are going to add on. So here this is a problem, annually compounded. Okay, so the formula is same as usual. Calculate the future value of rupees 50,000 at the end of third year at 12% rate of interest, that is annual rate of interest. Here, the word simple interest is not used, right? So what is this? Simple interest is not there in the problem. And they have not even written compound interest. So if this is barely given likewise, annual rate of interest is given, we need to make an assumption that it is annually compounded. Okay, so what assumption we are doing here? It is annually compounded. Okay, so usual process is the same thing only. If it is quarterly given in the problem, then no probs, quarterly compounded, semi-annually compounded, monthly compounded, whatever. If nothing is given, then we need to assume that annually compounded. Here 50,000, let us calculate what is the future value of rupees 50,000 at the rate of 12% interest and for 3 years. Okay, now the formula we have written is same. Future value is equal to present value or a principal amount 1 plus I raised to n or 1 plus r raised to n. Both are one and the same. Let's come to this calculation. 50,000 I have taken, multiplied by 1.12. 1.12 is 0.12 is meant for what? 0.12 is nothing but rate of interest. Okay, 12 divided by 100, the answer you get is 0.12. So this 0.12 is added to 1, then the figure we get is 1.12 raised to 3 years. How many years? 3 years. So 3 times we are multiplying 1.12 into 1.12 into 1.12. If we multiply 3 times, then we get the factor. This is compounding factor, we call it as, that is 1.405. 1.405 is multiplied to rupees 50,000. Then we finally get the future value. What is the future value at the end of third year at the rate of 12% interest is annually compounded is 70,250, right? Using this formula also you can do. Either of these formulas are okay. No, there is no doubt in this. Okay, let's move on to the next problem. This is asked in the question paper, Karnataka University question paper 2014, KUD, Karnataka University, Dharwad. Okay, so the problem is rupees 20,000 invested at 5% compounding annually for 10 years. So what is this? Rupees 20,000 invested at 5% compounding annually for 10 years. 20,000ನ 10 ವರ್ಷಕ್ಕೆ 5% ಬಡ್ಡಿಗೆ ನಾವು ಇನ್ವೆಸ್ಟ್ಮೆಂಟ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ. Then find out the future value according to compounding value table. Rupee 1 for 10 years at 5% interest is 1.629. This is readily given to you. It's a ready-made food to you. You're not supposed to calculate anything. What you're doing? Write the formula. Coming to the answer, write the formula. We have written the formula, that is FV is equal to P1 plus I raised to n, or FV is equal to PV1 plus R raised to n. Both are one and the same. So write down the P is principal amount, the amount what you are investing, present value amount is rupees 20,000. multiplied by the compounding value factor. This is what is known as CVF. CVF is nothing but compounded value factor or compound value factor. Okay, CVF is nothing but here it's written, CVF anta bardideyalla illi. P multiplied by CVF, present value or principal amount is multiplied by compound value factor. Compound value factor. Okay, so it is also called as CF. CF antanu helbodu athwa CVF antanu helbodu. Here the formula written in this way, it's a simple formula. Future value is equal to principal multiplied by CVF at 5% interest for 10 years. See, this is the symbol which is used most commonly. CVF at 5% interest for 10 years. How to read this? This is the way we are reading it. Okay. So P is, here in this case, P is how much? P is 20,000 rupees. 20,000 multiplied by CVF is readily given in the problem 1.629. That itself is equal to 32,580.